All right, pre-calculus, we're here with 3-3, building the unit circle. Still introducing kind of the background for our trigonometry. Not even going to mention the sine, cosine, and tangent in here today. So, a couple questions with this one, so make sure you answer them both as we go through. Here's what we're going to do. We talked about what the unit circle was on the previous video. We know it's a circle with radius 1 is what we know. Okay. We know it has a center at 0, 0. And that makes it the equation x squared plus y squared equals 1. That's the algebra that will eventually connect us to the trigonometry. Right now, we're going to just look at how the triangles we looked at yesterday relate to the unit circle, how we can use that, the angles in standard position. When we draw an angle in, that angle goes through a point on the circle. How can we find the coordinates of those points for certain triangles? That's what we're going to work on here. Those points are going to be very important as we go through with the all the trig stuff. With those points, x and y, to connect them to a circle, well, we have a triangle drawn in. Remember, x is just a horizontal direction. That would be going across down here. Y is a vertical direction. That would be going up. If we draw in a radius, we just made a right triangle. We're getting closer to our connection with trigonometry. So that's a right triangle there. The angle in standard position is right in here at theta, and that x and y will determine our point. Now, as we go around the circle, other important things that we already know, this is way back before algebra, we know the signs of a point in each region. So each of the quadrants, remember, quadrant 1, quadrant 2, as we go around counterclockwise, quadrant 3, and quadrant 4. So positives in the first quadrant, we have the x positive, but y, or x negative, y positive in the second quadrant. Both are negative in the third. Then we have a positive x and negative y in the fourth. We're going to get all that together today, along with some of the triangles we did in the previous video, and figure out these different points that are going to be important for us. So, how do we find those coordinates? Well, some of them are really easy. We're going to start with quadrantal angles. So quadrantal angles are each of the angles on an axis. They separate the quadrants. That's what they're called. Now remember, we have a radius of 1 on our circle. So from the center to any point, there is 1. Now, if you just know that much, I think you can get all the points for each of these angles, remembering where these angles are. So, I mean, you can either even answer a question just like this pretty easily. All right, so if you could answer that one, you've already found one of these, because first one, 0 radians. 0 radians has no opening. It's right here on the x-axis. And like the question just had, if we go to the right one, well, we're over here at the point 1, 0. That's what the point means, right 1 up 0. That is a point on the unit circle. So go around and fill out all those others, just depending on whether you go up, down, left, or right. The radius is 1. So pi over 2, remember where these are. Pi over 2 was 90 degrees. We're still relating these back to our degrees here. So the point right at the top, 0, 1, up 1. Pi over here on the left. So let's write this in. 0, 1, pi. Go to the left one, we're at -1, 0. And down here, that one was 3 pi over 2. X is 0. Y is -1. We're at 1 in every direction here. Just when we go left or when we go down, it's negative, and we have to get it in the right position, X or Y. Now remember, 2 pi, that's our 360. We're back at the beginning of our circle. So 2 pi, same as 0. We're back to 1, 0. So going all the way around, the quadrantal angles, well, those all have x values of 1, y values of 0, or the opposite. Okay, all of these are combinations of zeros and ones, zeros and -1s sometimes. So those are the first coordinates that we want to know. Also, if you check out things like domain and range, that means on this circle, the domain and range are both -1 to +1. Those are the highest and lowest values we're going to find on here. Okay, so -1 to +1, 0 is when we're on an axis. Those are the first ones. So we're going to start building these. Most of the homework on 3.3 is just saying, what are the coordinates at this angle on the unit circle? So all the quadrants, there we go. Okay. Well, let's see about other ones. That didn't take too long for those first ones. So other angles. Well, let's do a little bit of quick review here. Other angles that we're going to find are based on special triangles. We had previously that we wanted to memorize certain radians. Those were pi over 6, pi over 4, pi over 3, pi over 2. And those were the 30, 45, 60, and 90. Those are our special triangles. So first one here, 30, 60, 90 triangle. Those are the angles. Now, on our unit circle, when you draw the triangle on that first picture, take a quick look at where parts were there. The hypotenuse was 1. So if we're going to make a triangle out of this, the two legs are the x and y, which give us the coordinates. The hypotenuse is what always stays the same as the radius of that circle. It's always 1. So instead of just writing out a pattern here, this is the certain one we want to know. What if I put a 1 on that hypotenuse? Can we fill in the rest? Well, of course we can. Or we have over here the short leg across from 30. We have the longer leg across from 60. The hypotenuse is 1, and that is always the double side. It's been doubled to get to 1. That means if we go back, short side is 1/2. The longer leg then was the √3 side. It's short leg times √3. So we have 1/2 times √3. I'm just going to make this √3 over 2, just as one fraction. Instead of 1/2 times √3, √3 over 2. If we know that triangle, we can get the coordinates around the circle of the important angles we know. Same thing with the other one. The other one was the 45, 45, 90 triangle, isosceles. And what happens if its hypotenuse is 1? Remember, going backwards, this is a x, x, and x √2 triangle. So we got to divide this by √2. That means the legs are 1 divided by √2. I'm just going to leave it that way, not even rationalize. 1 over √2. Now, if you learned last year, and remember these numbers, √2 over 2, that's the rationalized form. You don't need to rationalize this for me. All your answers are going to be given in this form. Either one is correct. Make sure you can check your answers. And 1 over √2 is just a little bit better to use anyway for certain situations. All right, let's see how that works then. So what if I ask you to give the coordinate point, that's what all these are, coordinate point right here, where a 30-degree angle, which is what in radians? Make sure you know these. 30 is pi over 6. Should have gotten that right. Pi over 6. So we're going to keep connecting those until we're all into radians. All right, pi over 6. So what is the coordinate point? Right there. We want to know the x and y. Well, some of these are based on the triangles. We know we have a radius of 1, and that will be the hypotenuse. Because the x value goes across the x-axis horizontally. The y value is vertical. So when we do that, we have made a 30, 60, 90 triangle. Look at the way it's positioned, and this is the one we just did. 1 on the hypotenuse. Across from 30 must be 1/2. Across from the 60, which is up by the point, must be the √3 over 2. That just gave us our x and our y. So x is √3 over 2 comma 1/2. That is the coordinate point for a pi over 6 angle where it intersects the unit circle. So about 45. Another special triangle right here, that point. What is it? Well, let's draw in hypotenuse. We have a y value. We have an x value, right triangle. This is a 45-degree angle, or in radians, that is pi over 4. All right, so for pi over 4, let's see. 1 is always the hypotenuse, unit circle. Divide, and these were 1 over √2. That was our triangle in the form of the hypotenuse of 1. That means the coordinates for this one in there are 1 over root 2, comma, 1 over root 2. Okay, you can see how these triangles are working. So next one, 60 degrees. 60 is pi over, that's 3. Okay, coordinate point right there. Well, if we go straight down and across, drawing our triangle, hypotenuse of 1, we have a 60-degree angle by the origin. Right angle 30 would be up here. So for the 60-degree angle at the origin, we have 1. The bottom, the horizontal, the x is the 1/2. The y, or the vertical, is the root 3 over 2. So that is 1/2, comma, root 3 over 2. If we get to know those better, that helps us with all of the others. But that's how we're going to start these. How do we get this triangle? And what we want to realize here is we don't want to have to draw triangles every time. But have a general position of these. 30-degree angle was much lower and farther to the right. Okay, so the long side was the right. That was the x. The short number, the 1/2, was the y value. On a 60-degree angle, well, that's a lot shorter out to the right. Okay, the short side is on the x, and the longer leg, it's going up. 60-degree angle is up farther. So I have the longer side, the root 3 over 2, for the y value. So if we can think about this as a short leg, long leg idea, and we have this idea of this one hypotenuse triangle with a 1/2 root 3 over 2, we can start doing these pretty quickly. So the more practice we do, quicker we'll know all these points. So let's go on. And what about others? Well, here's what you have to do. You've got to know the first quadrant. So we're going to look at patterns on this, and the more we use it, the better you get to know this. So what do we have in the first quadrant? First of all, these are our degrees that are over here in this table. I'm going to put it on the drawing. I'm going to put it on the table, whichever one works best for you. Keep looking back at it so that you get to know these numbers. And eventually, we'll connect it to trigonometry. So first of all, you should know these radians. 0 degrees, 0 radians. 30 pi over 6. 45 pi over 4. 60 pi over 3. And 90 is pi over 2. So we've got 0 all the way up to pi over 2 on our picture. And here are the other pieces. Okay. We've got our 30-degree angle is pi over 6. Top one is pi over 3, and the middle is pi over 4. These points, along with the quadrantal angle points, are the ones we want to be able to find. And we just did all of these. Okay. The coordinate point at 0 was right 1, up 0, 1, 0. We can do the pi over 2. That was the 0, 1. Okay. In the middle, let's see, label these on the picture, 1, 0, and 0, 1. Pi over 6. And here's a picture you can see. Now our numbers, here's what I want you to start thinking with. The numbers we have, there was only 5 of them. 0, 1, smallest and biggest here. The others were 1/2, 1 over root 2, and root 3 over 2. In order, that is 1/2, 1 over root 2, and root 3 over 2. That is in order from smallest to biggest. So if we just look at these, the pi over 6 is the biggest x value. It's the farthest to the right. So out of those 3, the 0s and 1s are only at the coordinate angles, or the quadrant angles. Out of the middle 3, the biggest number is root 3 over 2 for the x. That's the farthest right. Well, it's also the shortest one going up, and that's a y value. So the shortest number, the smallest number, is 1/2. So pi over 6 is our root 3 over 2, 1/2. You don't have to draw a triangle if you know these numbers. Pi over 4, that's in the middle. That's our 1 over root 2, 1 over root 2. Pi over 4 is 45 degrees. That was isosceles. Both the x and y are the same. That's the middle number for both. And the 60-degree angle is pi over 3. And that one, pi over 3, is the tallest one. So that's got the biggest y value. That's going to be the root 3 over 2. But it's the shortest one out to the right, so the x value is small. That's the 1/2. So know the smallest to biggest there, so you can identify short and long, or farthest out, farthest up. Shortest out, shortest up. And get those in the right places. Our 60 degrees was 1/2 root 3 over 2 for pi over 3. Okay. So get all that, make sure you have it all copied out so you can keep referring back to it until we really get to know these numbers really well. We've got to know this first quadrant, all the degrees and radians that are in there, where they are, and all those coordinate points. That helps us because that's what the rest of the circle is based on. So let's move to other quadrants. How are we going to connect these other quadrants? Because if we end up at, say in degrees, something like 210 degrees, that's one of our special angles in another quadrant. Well, you can't fit a 210 degrees in a 30, 60, 90 triangle. So what do? Well, we have to relate to all those triangles. So other quadrants, know the reference angle. We're going to kind of two big pieces. The reference angle that is now connected to a point, and the signs we already know. Well, all it is for the signs. Let's look at that first. The signs just say in the first quadrant, it's what we did first. These are positive, positive. Okay? The only difference is as we move around the quadrants, we might have some negatives. Second quadrant has a negative x, positive y. Third quadrant, negative x, negative y. Fourth quadrant, positive x, negative y. That's what we mean by the signs. So we have to know where we are, and we'll know the signs of our coordinate point. Well, the other thing is the reference angle. So what is that? The reference angle. The reference angle is always going to be either, well, we can have those first quadrant angles. I guess we could have 0, but it's pi over 6, pi over 4, pi over 3, or the other quadrant up to pi over 2. It's all a first quadrant angle. This is defined, the reference angle, to relate to those, it's defined as the angle between the terminal side, so we know what that means, terminal side, and the closest x-axis. Usually we said our angle starts at the positive x-axis. Well, we want the closest on this one. That's going to give us a first quadrant angle. That's the angle between there. Let's look at 120 degrees to give an example of this. We'll look at the other ways you can do this. So on 120 degrees, 120 degrees terminal side is what we're going to draw. That's bigger than 90, so we are in the second quadrant over here. That is about 120 degrees. Okay, 120 degrees measures this side. So the reference angle is between that line and the closest x-axis. Well, the closest x-axis to this would be going down to the negative side. It would be this piece of the x-axis here. So that is the angle we want to find. Well, we know we're at 120 now. The x-axis on this side where we're closest to is 180. So what's the difference between 120 and 180? That is a 60-degree reference angle. So we got 60 degrees for that first one. That's the idea behind this. So it always goes to the x-axis that's closest to it, okay? Or the part of the x-axis that is defining the quadrant that we're in, but it's always with the x-axis, okay? So 210, let's look at that one. 210 goes all the way around to the third quadrant. It's bigger than 180. Well, let's see, there's 210. Here's 180, so what is the angle between there for the reference angle? That angle is 210 minus 180 is 30 degrees. So that's a 30-degree reference angle. Now, where have we done this before? Well, we did this when we were converting radians and degrees. You were looking at multiples. Out of those special angles, which is the biggest one, that is a factor of 120, okay? That means 120 is a multiple of that. 60 is for 120, so that's its reference angle. 30 is the biggest one that goes into 210. 315, what do you think for that one? Well, 315, clue is it ends in a 5. The only one that ends in a 5 is a 45-degree angle. If I give you degrees, you should give me a degrees reference angle. Well, what about radians? How do we do that with radians? Because it's pretty easy to draw in 315 is down in the fourth quadrant. And the closest one then is going to be 360, not 0. That would be going way back around. 360 is the closest one. So between there, subtract, and you get 45. That's easy with just whole numbers that we're used to. But what about with radians? I'll tell you what, it is even easier. So the long way would be to try to draw it in, find the closest x, and do the subtraction like we did with these numbers over here, 350 and 360. Even easier, it's already built in. Now, 5 pi over 3 is closest to 2 pi. Okay, the difference between those is 1 pi over 3. Well, the reference angle is right there. Take away the coefficient. Pi over 3, that is 60 degrees. That's the reference angle. So pi over 3. That makes it real easy. 5 pi over 6. Pi over 6 is the reference angle. Okay, 5 pi over 4. All these have the 5 on there. Just pi over 4. Pi over 4 is the reference angle. Well, so easy you can do one yourself, like this one. All right, so that one hopefully was pretty easy. The only thing you have to look for is something like this. Let's say I gave you something like 8 pi over 6, just because I'm being mean. The reference angle on that one is not pi over 6. Reduce first. So before we get 8 pi over 6, reduce, and that's 4 pi over 3. So its reference angle is pi over 3. It's always need to be reduced first, so you can tell me the reference angle. Okay? So what does that reference angle mean? Well, the reference angles are the special triangles, and those are the first quadrant angles. So I said there's two things here, reference angle and sines. The reference angle is going to give us the numbers in the coordinate point, like we know from the first quadrant. The sines, that just tells us positive, negative for x and y, as long as we know where we are. That's the quadrant we're in. So let's put those two things together. Find the coordinate point for 5 pi over 3. All right, well, pi over 3, let's go through these two. Without even drawing it, I know the first one, the first part, and that is the reference angle. The reference angle in this one, pi over 3. Now, pi over 3 means we have an ordered pair of, we'll just get better with these. Pi over 3 is a 60 degree. Always keep connecting those. So that's the tallest one. Remember, pi over 3 is the tallest out of those, or 60 degrees is the tallest. So that is the biggest y value, but the smallest x value. 1/2 root 3 over 2. Okay, pi over 3, even if I draw that in the first quadrant, short way on x, long way on y. Short side, long side for those. Okay. Now, other thing I need is what quadrant are we in so I can get the signs right? Is it positive or negative for 1/2 root 3 over 2? So I'm going to go with quadrant to know what the signs are. That's why we need it. So the quadrant here, 5 pi over 3. Let's see, how do we know what quadrant we're in? I think we mentioned an easy way yesterday. Remember, over here is 1 pi. Okay? So 5 over 3 is bigger than 1. So we're past the first and second quadrant. Okay? So 5 pi over 3. The next one is 3 pi over 2. One way to do it is to think 1/2 is 3 over 2. 5 over 3 is more than 1/2. It's 1 2/3. So 5 pi over 3 is actually in the fourth quadrant. So fourth quadrant. Another way to think about that. The 5 over 3, if we're comparing it to 1, if the numerator is smaller than the denominator, we're in quadrant 2. If the numerator is just 1 bigger than the denominator, that's bigger than 1, we're in quadrant 3. And 5 over 3 is more than just 1 bigger. 5 is 2 bigger than 3. What we're looking at is actually, it is 1 less than 2 pi. So 2 pi would be 6 over 3. That's 5 over 3. That's one way you can start thinking about what quadrant we're in. So the signs in the fourth quadrant are positive, negative. Put those together. That's why we did it. So reference angle, we have our coordinate point. Quadrant we're in gives us our signs. Put those together and we have our answer. This is positive 1/2 negative root 3 over 2. Okay? So be able to build this up. What about 3 pi over 4? All right. You guys can stop and think about this. First, reference angle. Pi over 4, that means our coordinate point is, or the numbers, 1 over root 2, 1 over root 2. Pi over 4 is always going to have the 1 over root 2's. The quadrant that we're in, or the signs that we're going to get. I'll probably just always say the quadrant that we're in. 3 pi over 4, let's see, 3 pi over 4 is less than 1 pi. It's 3/4, so it's 3/4 of the way around the first quadrant. We are in the second quadrant here. That is our 3 pi over 4. So quadrant 2 means negative x, positive y. Put those together, negative 1 over root 2, positive 1 over root 2. There's our coordinate point. Okay, refer back to the first coordinate work that we did in your notes up above to make sure you can grab those real easy and get used to these. All right, 7 pi over 6. You guys try it first. All right, just pause if you need to. 7 pi over 6. We've got reference angle pi over 6. I'm just going to draw in the first quadrant here. Pi over 6, shortest one. So if you're not looking back right now, that's good. Try to get it without looking back, but then check yourself. That's the shortest. Pi over 6 is the shortest one. That means the smallest y value, which goes with the biggest x value. It's the farthest to the right. Root 3 over 2, 1/2. Okay. Now, 7 pi over 6. Where are we? Well, 7 is bigger than 6, so we are bigger than 1 pi. But it's just 1 bigger, 1 pi over 6 bigger. That means we are down here in the third quadrant. There is our 7 pi over 6. The numerator is 1 bigger than the denominator. You see that straight across from the pi over 6 if we continue those through. Okay, that's why it's the same reference angle. So we are in the quadrant of 3. And that means negative x, negative y. Put those two together, and we have negative root 3 over 2 and 1/2. Okay, there's the coordinate point right here. Negative root 3 over 2, negative 1/2. I said the right thing, wrote the wrong thing. That is the coordinate point there for 7 pi over 6, negative root 3 over 2, negative 1/2. All right, that is what you're going to be putting together for the page on 3.3. Remember your problems on here. We're not doing them all. We're cutting down to the essentials here. Worksheet 3.1, 1 to 21, not the back side. So a lot of these should be going quick. A lot of geometry review in there. 3.2 should be very quick. That's the convert radians and degrees. So knowing the multiples on that one. That was just 1 to 30, even though there's 30 there. Goes pretty quick. Just radians, degrees, and degrees to radians. Look at that first quadrant, those ones we had memorized, and look for multiples. And 3.3, we're doing 1 to 27. There's a few kind of weird radians and degrees to convert to see if you can follow through with the pattern a little bit more. But then it's find a lot of coordinate points. Do just what we did here. The reference angle, refer back to our little table we made and start getting to know those, or think about short side, long side as you look at the picture. And then what quadrant are we in? That should give you the signs. Okay, that's those type of problems on 3.3. That's all the background for the unit circle before we start connecting these to trigonometry. All right, we will see you guys virtually next week, and we'll see what else we can do with the unit circle and getting into trig. See you then.